Deductive reasoning, also deductive logic or logical deduction or, informally, top-down logic, is the process of reasoning from one or more general statements to reach a logically certain conclusion. Deductive reasoning links premises with conclusions. If all premises are true, the terms are clear, and the rules of deductive logic are followed, then the conclusion reached is necessarily true. Deductive reasoning contrasts with inductive reasoning in the following way. In deductive reasoning, a conclusion is reached reductively by applying general rules that hold over the entirety of a closed domain of discourse, narrowing the range under consideration until only the conclusion is left. In inductive reasoning, the conclusion is reached by generalizing or extrapolating from initial information. As a result, induction can be used even in an open domain, one where there is epistemic uncertainty. Note, however, that the inductive reasoning mentioned here is not the same as induction used in mathematical proofs. Mathematical induction is actually a form of deductive reasoning. Simple example, an example of a deductive argument: all men are mortal. Socrates is a man. Therefore, Socrates is mortal. The first premise states that all objects classified as men have the attribute mortal. The second premise states that Socrates is classified as a man, a member of the set men. The conclusion then states that Socrates must be mortal, because he inherits this attribute from his classification as a man. Law of detachment. The law of detachment is the first form of deductive reasoning. A single conditional statement is made, and a hypothesis is stated. The conclusion is then deduced from the statement and the hypothesis. The most basic form is listed below, P a Q, P, Q. In deductive reasoning, we can conclude Q from P by using the law of detachment. However, if the conclusion is given instead of the hypothesis, then there is no definitive conclusion. The following is an example of an argument using the law of detachment in the form of an if-then statement: if an angle satisfies 90 a degree A less than 180 a degree, then A is an obtuse angle. A equals 120 a degree. A is an obtuse angle. Since the measurement of angle A is greater than 90 a degree and less than 180 a degree, we can deduce that A is an obtuse angle. Law of syllogism. The law of syllogism takes two conditional statements and forms a conclusion by combining the hypothesis of one statement with the conclusion of another. Here is the general form: P a Q, Q a R, therefore, P a R. The following is an example: if Larry is sick, then he will be absent. If Larry is absent, then he will miss his classwork. Therefore, if Larry is sick, then he will miss his classwork. We deduce the final statement by combining the hypothesis of the first statement with the conclusion of the second statement. We also allow that this could be a false statement. This is an example of the transitive property in mathematics. The transitive property is sometimes phrased in this form: A equals B, B equals C, therefore A equals C. Law of contrapositive. The law of contrapositive states that, in a conditional, if the conclusion is false, then the hypothesis must be false also. The general form is the following: P a Q, Q, therefore we can conclude P. The following are examples: if it is raining, then there are clouds in the sky. There are no clouds in the sky. Thus, it is not raining. Validity and soundness. Deductive arguments are evaluated in terms of their validity and soundness. An argument is valid if it is impossible for its premises to be true while its conclusion is false. In other words, the conclusion must be true if the premises are true. An argument can be valid even though the premises are false. An argument is sound if it is valid and the premises are true. It is possible to have a deductive argument that is logically valid but is not sound. Fallacious arguments often take that form. The following is an example of an argument that is valid, but not sound: everyone who eats carrots is a quarterback. John eats carrots. Therefore, John is a quarterback. The example's first premise is false: there are people who eat carrots and are not quarterbacks, but the conclusion must be true, so long as the premises are true. Therefore the argument is valid, but not sound. Generalizations are often used to make invalid arguments, such as everyone who eats carrots is a quarterback. not everyone who eats carrots is a quarterback, thus proving the flaw of such arguments. In this example, the first statement uses categorical reasoning, saying that all carrot eaters are definitely quarterbacks. This theory of deductive reasoning, also known as term logica, was developed by Aristotle, but was superseded by propositional logic and predicate logic. Deductive reasoning can be contrasted with inductive reasoning, in regards to validity and soundness. In cases of inductive reasoning, even though the premises are true and the argument is valid, it is possible for the conclusion to be false. Education. Deductive reasoning is generally thought of as a skill that develops without any formal teaching or training. As a result of this belief, deductive reasoning skills are not taught in secondary schools, where students are expected to use reasoning more often and at a higher level. It is in high school, for example, that students have an abrupt introduction to mathematical proofs, which rely heavily on deductive reasoning. See also. References. Further reading: Vincent F. Hendricks, Thought to Talk, A Crash Course in Reflection and Expression, New York, Automatic Press/VIP, 2005, ISBN 87-991013-7-8, Philip Johnson Laird, Ruth M. J. Byrne, Deduction, Psychology Press 1991, ISBN 978-0-86377-149-1 Jim Zarifsky, David, Argumentation, The Study of Effective Reasoning Parts I and II, The Teaching Company 2002, Bullimore, Thomas, The Pragmatic Problem of Induction. External links: Deductive Reasoning at Phil Papers, Deductive Reasoning at the Indiana Philosophy Ontology Project, Deductive Reasoning entry in the Internet Encyclopedia of Philosophy.